Okay, so chapter 14 deals with JavaFX. We will not complete the entire chapter today. And as you can see, if you look at the course calendar, we're actually doing only about half of that. And the reason is because I want to make sure that we understand, we have a pretty good understanding of what JavaFX is, because this is the foundation of for the rest of the chapters. Okay, so as you can see, we're doing that today, and you are only going to do the assignment 1. So there are 2 of them. So you do part 1, and then you can do part 2 next time. It doesn't mean that you shouldn't do it now. I mean, you can do both of them at the same time. It's fine. It's up to you. Okay, so we will continue again next week. Of course, we'll have class next week, but will be co-lectures for the rest of the anything that is not being discussed tonight. And so by that time, or if you read chapter 4, and again, I'll also find some other videos to help you as well. You should be able to complete both assignments. But it is important to understand the foundation of the GUI interface that is used in Java. Okay, so if you don't understand the chapter 14 or the things in chapter 14, then you will have a problem with the upcoming chapters, 15, 16, and the rest of the pretty much the rest of the other chapters, because they all deal with kind of similar interface. Okay, so let's go over the note here for what I have here. Okay, I'm not going to go too much into the history of JavaFX or the GUI interface, but just a brief history of where they came from. Okay, so Java was again created back in the early 90s, right around when the World Wide Web, came into existence, became very popular, and then they also want to get, of course, the initial idea for Java was to build for all types of machines, right, devices, from your cars to your microwaves to your anything that you can touch with like the remote control, all the stuff. But when the web got really hot, like in the mid 90s, and then everything became a lot of has a lot of GUI interfaces, like Microsoft Windows. You remember 3.1 and 3.5. I mean Windows 5, Windows 95, and then so on. So and then the web just took off like crazy in the mid 90s, and so Java also want to take a part of being part of this revolution. So they came up with a way to build some GUI objects. And if you remember, if you are a web developer, or if you have experience with that, in the 90s we have something called the applets. Okay, applets are like Flash applications that is integrated into a web page, and applets are tiny applications that is built using Java code. So it's no longer used today. It still is. Maybe once in a while you might run into one of those, just like Flash, but it's kind of died out because of the HTML5, right? So that can pretty much. So HTML5 pretty much killed the applets in the Flash. But anyway, so back in the day, Java came up with this tool called the Abstract Windows Toolkit, or AWT. And then, so there are 3 versions since then. We have the Swing, and then the JavaFX, which is the current version. So the AWT was pretty much used to build this graphical user interface, or this GUI design. And when they did that, they have, as you can see at this chart here, if I can hide these, this is what it was like when they first built this AWT framework. So as you can see here in Java, right, everything is a subclass, either directly or indirectly, of the object class. So the object is the ultimate object of all other objects in the Java program. So, and then the GUI interface is pretty much what you see here on the right side. All of these are part of the GUI interface, the AWT. They are a subclass or children of the component class, which is a child of the object class. And down here they have the window, and then the panel, and then they have the applet here, right? This applet is used for the web interface, and then we have the frame and dialog box for the application, like console applications. And so here is an example of the code that you would write in AWT. And the problem with the AWT is that it's a console application, and then most of the interface, of the designs, the controls, like the button you see here, are conformed to the local machine. So they are system dependent. So if I build a application for Windows, the buttons will look exactly the Windows buttons. And now if I move the application to run on the Mac, you have a different button design because it's based on the Mac's buttons. And if you move that to a Linux, you get the same thing. So it's not really consistent. It's always different. And sometimes you also have issues where, you know, a certain code does not work well with Mac and vice versa, and it can cause your system to crash. And so don't try to run these at home, I mean, on your computer. If you do, you might have the same issue. I tried it before, and I tried to just take a screenshot of hopefully as you can see it. But I did that on my machine. What happens is that because it's not compatible with my laptop, when I run it, then that window is never closed. You can't close it. It just froze. It just stayed there. And the only way to do that is just to reboot your system. Okay, so that's we have those kind of issues with the AWT. So that is one of the major issues. It's freezing systems because you cannot build one system or one program to work with all other different systems. Imagine Windows has an update, right? Now what? You have to update your application to match their updates. And then they have the Mac updates, you have the Linux updates, and so that's pretty tough. So that was the issues with the AWT, and then they came up with a new one called Swing. So Swing is the one that was built to prevent platform-specific bugs. Okay, because we just mentioned that because they are dependent on the systems, they want to have one that is consistent throughout. Okay, so the Swing was the solution for that one, and it was replaced. So the AWT was replaced by the Swing library, and so the Swing is much more robust, more versatile, flexible, but then they have an issue because it's not web friendly. Okay, so there's another issue there, and this is right about I think right around like the turn of the Y2K era, and so. Now it's nice, right? See, if you look at this diagram here, it's a little bit different now, but you still have part of the AWT parts over here, okay? And then they added a J component as another separate class for the component class. So this is the AWT, just this part on the left side here, and then this part is all the Swing class. You call this, so you see the J table, J list. J component. You see, if you remember, you did that some of those in the Java 1 class, where you create a little prompt window using J option pane. Okay, those are part of the Swing class. Okay, so it was pretty good. It was robust. As you can see, if you look at the system here, the output here, the Windows 10 and Windows 7, different systems, but if you look at the button itself, they look very much the same. Okay, I don't have a Mac, so I can't get the output of that, but it should still look the same. So now it's not system dependent anymore because all the objects, how you maintain these buttons are not depending on the system, but they have their own sets of images to make that throughout. Only thing is that it's not web friendly. Okay, so we have another one coming up. But anyways, here is a table to compare those two, the AWT and the Swing. This is a really slow process because again it relies on the system's resources, right? It depends on the local system to use all their resources, the APIs to build the button, the text fields and so on. So it takes a lot of system resources. Whereas over here is all based on the code that the Swing provides. So it doesn't depend on the local system. Okay. Again, platform dependent, we have platform independent, and of course something called the MVC framework, okay, a model view controller. AWT does not support that, whereas Swing does. Again, this is another framework how you can write object-oriented programming using a different framework, and you will get to do the MVC controller framework later on in the web course or the object software development course. Okay, so then because of those issues, they come up with the next one. So what the next one, which is the current one now, is called JavaFX. Okay, so this one here replaces the swing components. I shouldn't, well, not really replace, but it's a more robust framework that will pretty much build on top of the swing. I mean, it fixed all the issues that AWT has. It would have all the issues, all the same components that the swing class has. In addition to that, it's now web friendly. Okay, so it can be built on any platform, on a desktop, okay, handheld devices, mobile devices, you know, tablets, even on the web. So that's why this is still the current framework being used today, and that's what we are going to learn, JavaFX. Okay. We'll talk about this code later. It will look something like this for the JavaFX. Okay, we'll deal with that in a bit. Again, we'll show you here again the JavaFX and the swing. So the buttons will look is a little bit different, and then down here it shows you like those three different frameworks and what they will look like. I can compare because it's not a different machine, but here I want to show you is the CPU times, the size, and so on. So kind of compare which one is more robust. Okay, so you can see that JavaFX, yeah, it takes more CPU time now, 0.32, because it deals with mobile and other issues. So the payoff is it's over here. You have the byte size, and then and so, and the virtual size is much smaller. So, but anyways, so let's look at this JavaFX, the anatomy of a JavaFX application. Okay, so JavaFX use something like, you can think of this example as a theater. Okay, you go to a theater show, and you are sitting inside the theater, the audience or the seat, and you see in front of you, you know, this curtain before they raise the curtain, or they remove the curtain, and then so you're sitting, so you're looking at the stage of a theater, and then in that stage you see what? A scene, right? You see a scene, you see actors, and a certain group of actors in a certain place, and they move, and actors are like objects, and so they do interact, and so on. So so in a scene, okay, in a scene that you're going to build in JavaFX, you're going to have something called the root object or root node, and then that root node can have a branch or node, which is called a child node. If you think about this, it looks as similar to a web page. Okay, and then that branch can have other nodes and so on. So we have branch and leaf nodes. Okay, so a leaf node is the node or an object that does not have any other child nodes. So that's the leaf, that's the end of it. Okay, so the generic diagram will look something like this. You have the root node, and you have three child nodes, and then under this one of these you have a branch, because this one here has children. Okay, so in a more specific diagram, if you think about these classes that is related to a JavaFX, you have a group. A group here is a container. You think of it as a container. This container here contains three different objects. So this will be like three different nodes, and this will be the leaf node, because there's no more, they don't have child nodes underneath those. But you do have another node over there called the region, and that region contains two child nodes. Okay, and so if you again use a different diagram, you can see that it looks something like this. It's in the code, for example. So when you design your application, you have what's called a stage. So the stage is nothing more than your window. Okay, so you run your application and you write the stage or create the stage. It is that window. just like you see here, or a tab. Okay, this is a tab, this is a stage. I have a stage. I have 3 stages. Okay, so you can have multiple stages run at the same time. Okay, you cannot have a stage running inside another stage, but you can have the code inside your stage code, so that when you run the stage, when you show it, it will pop up in its own separate window. Okay, so you can have multiple windows. If you have taken Java Visual Basic, probably you remember back in around like chapter towards the end of that course, you learn about different forms. Same thing. So here we have the stage, and then the stage has a scene. Okay, so a scene has objects, or we call these controls. Controls will be like, if you think of a web form, would be just your input, your buttons, your text, and so on, your labels. All those are controls. The same thing that they use in Visual Basic. Okay, and then this here, in the dashed box here, is what is depicted up here in the diagram. We see the group, and then the node, and then the child node, and so on. So these are just used to set up your scene. So this example here, the root node here is the StackPaint object, which is this box here. It's represented by a dashed border box. That is the StackPaint. We'll talk about paints later. You have many kinds of paints. Again, paint is just a container. So, and then the paint has a button. This button is the control. So the button is the child node of the StackPaint. Okay. It's just a really simple example here. And then if you have more buttons, then you have additional buttons underneath this pane here. And you can have another pane inside another pane inside another pane. You can nest those panes. Okay. You cannot, of course, you cannot nest a pane inside a button, but you can have a pane inside another pane. Again, a container within a container. If you think of a web page, it's like you have a div inside another div inside another div tag. Okay. So that's how it will look like visually, so we can have a better understanding of that. But really, so when you build your application, always start with a stage. Okay, you need to have a stage. A scene cannot exist without a stage. Okay, so you cannot have a scene and suddenly have it work. So again, you cannot have an application running without a window, right? So you need to have the window. So that means you have to create a stage object. And then once you get a stage object, then you can start to create your container to contain those objects or controls. Okay, so you need some type of pane, and one of them is a StackPaint, and we'll go over some of those. And then within the pane, you can have these controls, the buttons, the text, and then the labels, and you can put graphics in there, animations, put videos. It all can be contained in there. And then we have this pane, and then you need to put this pane into a scene. Okay, so the pane must be inserted into a scene, and then the scene is inserted to the stage, and then you have to show the stage. Okay, so you kind of look. If you look at this, you really kind of like a build from the inside out. Okay, so you build your buttons and so on. You add those to a panel or container. Once you have the container built, you add it to the scene, and then add the scene to the stage, and then you show the stage. Okay, so that's the way it is. There can be only one stage and then one scene. So one stage can only have one scene. You cannot have more than 2 scenes in a stage. Okay, so one stage, one scene, or one scene has one stage, vice versa. But you can have a lot of containers in a scene. Okay, you can have a lot of containers. You have a lot of controls in the scene as well. And that is the only one of the rules. So we'll see a diagram here later. So here's another example to show you in the book as well. You have the stage, you have the scene, and then you have a button, but really there's another layer here. We have the paint, the container. Okay. So if you run this application, you see over here, this window here, or these 2 windows here, are 2 separate stages, right? 2 separate windows. And then this container here, right below these X buttons here, is your scene. Okay, inside the scene you have this button called OK. It's a really big button, as you can see. It takes entire space here. Same thing here. There's another one. Okay, in this example, so you have two stages, have two scenes, separate scenes, and each of those scenes has a button. So if you look at this diagram here, it's also in the book. It's a little bit more clear. So this stage here, as you can see, this stage contains a scene. That's what these lines mean. Okay, that triangle, the diamond mean it's a composition. Remember we talked about composition before, right? So in your code you have if you see a diamond shape, that means that stage contains something. Okay. So so the stage here, as you see, the number 1 here means it's only one stage, has only one scene. Okay, you cannot have two stages at any given time. I mean, at the same area, and have two scenes. So one stage, one scene, and then they can have an unlimited number of panes and the other objects here. So the stage has a scene. The scene has what's called a parent. A parent here is a class that can contain any of these here. Okay, these are different kinds of panes here, and these are subclasses of the base class called pane. And then the pane here is a base class for these, but it is also a child class of the parent. So the arrow, the direction of these arrows here tells you which is the parent. Okay, not the other way around. So all of these here on the right side are child classes of the pane class. And then the pane class and the control, there's another one here missing, not shown here. It's called the group class. 3 of these classes are the child classes of the parent class. Okay, and then the parent is a child class of the node, and also the same with the shape and image view are also subclasses of the node class. Okay, so that means because the node is like the parent of all of these, right? So you can have a node inside a scene, and you can have like a H box, a V box. Again, these are all can be contained inside the scene as well. Only thing is that you cannot have, so a pane cannot have another pane. I forgot which one is it. Okay, yeah, we'll see those later. But I know that the way you see here, like the shape and the image view cannot be contained inside the control and so on. But we'll look at that in a bit later. One more thing I want to tell you about is this coordinate system. Okay, you may see this already. If you are not familiar with this, the Java coordinate system uses the same as the web coordinate system. Okay, so on the conventional coordinate system you see on the map is the one on the right. The x and the y axis crossed where they cross, that is the center of the coordinate system, is 0, 0. And then if you move to the right, that's the positive direction of the x, and the negative is the other direction. And then if you go up here on the y axis, is positive, negative, down. That's on the conventional or the regular coordinate system we use for math. But in Java and most webs and game programming as well, we have a different system. We pretty much like, if you take this, the bottom right quadrant here, and then you put that over here, that's our coordinate system. Okay, so we focus on this fourth quadrant here. So this is the first, second, third, fourth quadrant. You take that, and then that is our coordinate system. Now, the only thing is that we inverse the direction of the y-axis. So you kind of flip the y-axis down. So you start from the top left at 0, 0, 0, and then if you move to the right of this axis, you get the positive direction, same as down here. Negative is beyond, so beyond the top of your screen. So if you look at this screen, the top left is 0, 0, and then a negative direction is off screen. Okay, something when you build your website is the same thing. Then going down is positive for the y, and then going up is negative for the y. Okay, so make sure you understand this system. So later when we build the grid layout, if you move objects and on your scene, you know which direction to go. Okay. And we're not dealing with three-dimensional here. So if you do have the 3D, it will be the axis that is pointing directly out at you at this view. Okay, going positive this way, negative down. Okay, for the z-axis. All right, and then these are the I think 1, 2, 3, 4, 5, 6. Probably a little bit more. These are just 6 of them. I think there are a few more of the common panes that you can use when you build your application. Okay, so you have the pane again. If you look at the diagram earlier, the pane is the base class for all of these. Okay, and then you have a stack pane, flow pane, grid pane, border, H box. H box is the horizontal box. V is vertical. So that means if you add components into your H box, everything's going to stack from the left to the right in horizontal direction. Okay, and the vertical is the V box is just the opposite. It'll be going down in a single column. And then if it reaches the maximum of that vertical or horizontal, it will move on to the next line or the next column and so on. Okay, that's how you build your scenes. Very similar to how you build a game application or a mobile application. You have these kinds of panes there. And you'll see that one of these or some of these may be more useful than others depending on how you build your application. So the border pane is quite useful. You'll see that later because it has the layout that looks very similar to a web page. So you have the top, left, right, and the bottom and the center. So you can use the top for navigation, the bottom will be the same, and or which way we choose it. So something very common there. The grid plane is also really important, also interesting. You can use that to build your design really easily because you can choose grid based on columns and rows. You think of it as a table. So if you want to put a label called first name on the first column, the first row, and then after that you put a text box for the entry field. That'll be on the second column, the first row, and so on. So you have more control of that as well. So flow pane is kind of similar to the horizontal box because it will flow from left to right, and then it will also flow to the next line. The stack pane is different. This one here is it will stack your objects from just on top of each other. So depending on how you put your code in order, if you put the button first and the next line of code you put another button, then that's going to be laid on top of the other one. So you have a stack of objects on top of each other, and the last object is placed on the stack will be visible, with the rest will be hidden underneath it. So I mean you can still see if the size of those buttons or objects are long or big enough, but it will be underneath the latest or the last line of code. And you have more control of that as well. You can move those around. You're not limited to that location. You can move things around too if that's the way you want to design your code, design your application. Okay, so the stack pane, as you can see here, I have some example here. Stack, as you can, I have like 2 buttons here, and the button 1 and button 2. So the button 1 here too, and I add the button 2 first, and I add the button 1 second, last. So that's why you see that the button 1 is placed on top of the button 2. Okay. So before we go any further, I want to go into Eclipse, and we can start doing some examples. Just very basic setup of your application. So if you want to run it right now, we can go and build a simple application. Just pretty much go through the process of creating your stage, creating your scene, creating a pane, and then add maybe a button or 2 or even a label or text field, and we'll run it so we'll know what's like. Okay?